morning, everybody. My name is Davide Lombardi, as just said, and I work in Scienziato Liverpool University in Suzhou in the Department of Architecture. This presentation is mostly related to the work that me and my colleague, Professor Theo Dunas, in Antwerp University at the moment have been doing over the last couple of years, let's say, synthesizes also in our book, Blockchain for Construction. This specific case also with the help and super important support from Professor Basim Jabi from Cardiff University. Okay, I think that many of us would agree on the fact that we recognize the architecture industry and construction industry, to have 2, 3, or 4 common problems, likewise productivity, supply chain integration, and carbon impact. Especially the latter one is something that we already heard in several contexts, and I'm sure also in several previous presentations in this context. Now, if we look a bit at the data, we know already that the field of architecture and construction does not perform, often does not perform, and especially when it comes about a comparison with manufacturing industry, we don't really do very well. Well, even if I work in academia, I like to say we, as having a background in architecture. There are several reasons for this. Often is about the non-availability of materials, and nowadays, even to some extent, the manufacturing industry is suffering by this lack of materials. Of course, we can also say that the 4 years of COVID pandemic did not really help to exchange both solid things as well as knowledge. Inadequate level of supervision, which we may discuss a bit more later on. Skills shortage. Yes, we live in a much more integrated world. However, when it comes about industry, the level of skills, the level of knowledge is not yet there, mostly because of one reason, in my opinion, which is the killer of any advancement. The classic sentence, we have always been doing like this, so why to change? Of course, if we would spread even more skills, that would be a problem that we could overcome easily. Lack of proper tools and equipment, and this is what we try often to overcome via technology. So we produce BIM, we produce blockchain, we work with these tools, but those tools seem not to really have yet an integration and an impact on our industry. Incomplete drawings and specifications, especially when it comes about CAD drawings. We know this very well. We already heard about how scattered our industry is. A lack of digitalization, which is true, at the same time not really true, because there is a lot of digitization. It's how this gets used. Then if we look into companies like Nike, for example, or luxury brands, well, all of those work chain. And here we go again. We tend now to work on a globalized environment, so every problem can be probably solved by anyone in the world, but any problem becomes also bigger because of the connections we have. Okay, a problem in, let's say, here Hong Kong will be reflected in Chicago and will be reflected in New Delhi in a second, for example. So material and industrial approaches are not yet there where they should be. Again, digitization and skills shortage are common problems with the aforementioned umbrella. Sustainability requirements. We heard a lot from Lavinia in her presentation how important it is, the sustainability aspect, also in Italy, which is quite surprising to know, but yes, it is. It's becoming more and more something demanding. We all know the UN goals, which more or less are impacting the operations of everyone. And last but not least, of course, real-time data, which leads also to another point from my side, which is we are overwhelmed by data, but then those data are either not in real time or not really good. Last but not least, indeed, a few numbers, a few figures on environmental impact of the AEC industry. Sorry if some of the data are not really readable. I just had to shift the presentation a sec. The impact of material production. The big discussion ongoing on how concrete is impacting the environment, the parallel big discussion about how timber is going to impact the environment if used as main construction material. So all of those together have led me and my colleague Theo and Basim to think about possible solutions, and we thought, okay, we rely on technology, we like IT, we are digitally driven, but this may not be the answer or the only answer. So we thought about creating a solution via collaboration as a result of technology plus social behavior. I have to admit that while I'm very interested in all the IT aspects of blockchain, DAOs, dApps, and so on and so forth, I still keep in my mind that we are human beings, so some humanistic approach is still needed. So we looked into stigmergy, and to give some definition, it has been defined by Marsh as a mechanism of indirect coordination through the environment between agents or actions. And here we go, the word environment comes into place, not just as environmental design, not just as something to be saved, but something that we are surrounded from. Of course, another line that helped us a lot thinking for a possible solution from Eileiten, I hope I pronounce it well, which defines stigmergy as a state machine with production rules, where the rules affect and change the state, and the state providing feedback and direction on where the rules need to be applied within a body of work. This is a bit of a convoluted reference, I understand, but the other word that comes here into place is the change of state, which is something that we heard in the sector of blockchain. So that's why we combined the two, and we realized that that sentence above was framing the condition as a precedent, let's say, defining basically that the state and the action are as the consequences of the state, where the condition is the current state of the world, and the action can change this condition and update it. Well, all of those combined together have led us to define a framework. First of all, a simplified one, where you can see a stigmergic medium, where the state change gets recorded and takes place. There are agents intervening in this changing of states, and there are production rules and feedbacks. So in other words, the stigmergic medium, the one where the collaboration happens, is for us, of course, the blockchain. So the humanistic approach, the social behavior approach gets translated, if you want, into an IT operational device, which is the blockchain. Of course, agents can participate in the system, but only when defined as external to the blockchain actor. It's important also to mention that in our view, in this view, agents may or may not be part of the process, may or may not be aware of all the parts of the process per se, but they can intervene on it. So the medium of stigmergy, which comes, of course, also from concepts like ant colonies and behavioral of social animals, for example, like ants indeed, is forming the state itself and undergoes change through actions, whose, as I wrote over there, states are senses and conditions for other subsequent actions. So in other words, if you think when ants are building their own colonies, there is a sharing of information among them, which we cannot see, of course, but we know this happens. Likewise, the sharing of information and synchronized information should happen into the stigmergic medium. So the medium, in our case, as I already said, is the blockchain, carries the communication between subsequent actions, and each action is improving, updating, and modifying the state. So if we go ahead, okay, this may appear slightly small, but there should be a bigger version later. What we call collective digital factories are a form of decentralized autonomous organization, tackling through cryptoeconomics issues like waste, carbon footprint, performance, and productivity. So the main scheme, the main scheme that you see here can be divided into two parts, the upper part and the lower part. So the upper part sees the design agent intervening, so architects, stakeholders, civil engineers, whoever is involved in the AEC process, let's say, connected through governance tokens, which basically are there in order to design a series of to design and collaborate in assuming that the design work through smart contracts. So the factories basically are managed via 3 tokens that are used for incentivizing the work towards a common goal. Now, the common goal, of course, is divided as carbon and waste reduction, increasing productivity, and building performance. The above is connected then to the stigmergic medium, where I think I have to watch here. Yes, where the continuous evaluation happen. We envisioned that all of these design processes are working into a BIM model, which, however, we don't yet consider to be fully there in its implementation possibilities in the AEC industry. So basically, we have BIM models gets updated through continuous evaluation process recorded on smart contract. However, you can see a couple of boxes before and after the BIM models, which are linked to topologic. Of course, as I said, many of the solutions that we have at the moment come from technology. BIM is one of them. It has already been argued that probably BIM is not maintaining the promises of simplifying our life as architects, builders, civil engineers, and so on and so forth. That's why we envision these digital factories working via simplified methods, simplified representation methods, via topologic, which is an application running on Dynamo made by Professor Basim Jabi. So basically, topologic, it's leveraging on the a simplified description of buildings through topology representation in order to, again, to have the core of the information, but without all the redundancies of BIM models. So to draw to a conclusion, the overall loop works more or less in this way. We have agents designing in topologic and preparing basically and obtaining three models: a BIM model, an energy model, and a waste and circular economic model. The agents will then use governance tokens to develop the next design decision. And through those governance tokens, they can also take part to evaluation process and voting in order to identify what the next step is. This is also aligned with previous researches from us, where we basically envisioned collaboration systems via voting. Once this step is overcome, the state changes in the contract, and then the solution, let's say, or the next solution, or the selected solution within this sort of collaborative environment gets reflected against specific targets on the AC project. Of course, the smart contracts will allow the designers to get paid, to get rewarded, or to get a positive or negative feedback in case based on how the code is provided in relation to the design choice that has been selected. So in other words, an automatic system feeding back directly to the design agent. Once the design agent earns a higher value on the fund against the proportion of the stake tokens, those can be retrieved via funds, and the designer can run again the process in reverse. Once we reach the fourth step of this closed loop, let's say, that indeed involves design tools, digital factories, and smart contracts, the loop can go ahead, of course, to the next iteration till an end that has to be reached, or can just drop there if the solution proposed can be considered as acceptable. Now, all of those can work even better if we go to the next step, which is exactly what we are studying at the moment. So that's why it's just one line, which is cross-disciplinary regulation, verification, and compliance processes. In other words, all the above when it comes about environmental regulations, when it comes about supply chain and so on, there is a foundation layer that we cannot really discard, which is a legal framework and compliance with regulation in individual nations, or even better when it comes, let's say, regulation that are continental, like in the EU or in the USA. So most likely the next step for our digital factories will be to embed also a system to verify the compliance against regulation. Thank you very much.